I have Sam Spencer. How's it going, Sam?
It's going well. Welcome. Hang on, let me see if I can.
No worries. It's all good, sir. So we got you talking about lessons learned by building the YARP proxy on .NET.
Yes,
Sweet. Are you ready, sir?
I am ready.
Take it away.
Cool. Hi everyone. Welcome to the last session of .NET Conf. If you've been watching all the way through, I admire your stamina. I am Sam Spencer. I'm a program manager on the .NET Runtime team. One of my areas of responsibility is the networking stack, and because of that, hang on, it needs to go this way, I think. Yes, we can probably go a little bit further. Yeah. Because of that, we had customers coming to us asking about a reverse proxy and proxy functionality, and we kind of decided, let's go build one, and that is YARP. So the naming of YARP is yet another reverse proxy. Other people look at it as like YARP or reverse proxy. It doesn't really matter. Naming is hard, but it's YARP. If I click in the right place. So what we're going to talk about today is what is a reverse proxy, and then what is YARP. We'll quickly take a look at the YARP architecture. I'll do a demo, and then we'll talk about what we have learned in terms of building YARP and using YARP as a proving ground for the rest of the .NET platform that we're built upon. So we've actually gone and modified HTTP client and Kestrel and improved them based on the learnings that we made from YARP. So what is a reverse proxy? If you're in a corporate or school environment, you may be used to a proxy server for use as a gateway to get outside your network. A reverse proxy is kind of the opposite. It generally sits behind your firewall, and it acts as a gateway between the internet and your services in your data center. So the advantage of putting a reverse proxy in there is it knows about the HTTP protocol, it knows about URLs, it knows about headers, it knows about all of those pieces, and so can map the URL space that you're publicly exposing onto a different layout as far as your actual data center architecture. For example, I have here orders and store go to two different sets of servers, and it can then load balance the requests across multiple servers. It also tends to be your front end, so it can offload work from the backend servers. The HTTP connection is terminated at the reverse proxy. It then makes a subsequent connection to the backend. So it can do things when it terminates that connection. Typically TLS, you'll terminate at the reverse proxy. You can do authentication and authorization. You can do compression, static file sharing. So if you've got images, CSS, things like that, rather than having to make a subsequent connection, you can just pull them off local storage and deliver them fast. Similarly with caching if necessary. So what is YARP? Well, YARP was a project. We had a number of teams come to us either asking directly for a reverse proxy or for functionality so that they could go and build or update their existing reverse proxy technology. And so we decided, let's use this as a proving ground for the .NET infrastructure and use it to kind of flush out any problems we might find. But also we had internal teams wanting the functionality. So we are what is known as a layer 7 proxy. If you remember your old OSI networking diagram from school, there's two kinds of proxies. There's layer 4 and layer 7. Layer 4 is what your Wi-Fi router will do at home, which is that's the network. The NAT or network address translation layer, that's just looking at the TCP connection and sockets and saying, oh, you want to go to this site in port 80, let me remap that to an external port and manage all that. That's all at the layer 4 level. It doesn't know what's going on inside any of those requests. Layer 7 is at the application layer, so it actually understands HTTP, it understands the request headers, and can make appropriate logic based on that. So your connection will come into the reverse proxy. It will then make subsequent connections out, and I'll show it in the architecture diagram, to your backend servers. And this allows you to multiplex the connections between incoming and outgoing. So over HTTP 1.1 and HTTP 2, you can have multiple request streams going on at the same time over the same socket HTTP connection. And so like you only have to negotiate TLS once rather than having to do it multiple times. So using a proxy to connect to a bunch of backend servers can actually improve the performance for their end users and not having to create connections to each of those individual servers. The reason why people came to us for YARP is they wanted to customize what they've got. Most of the existing proxies that are available are written in C++. They get hard. It gets pretty hard to make modifications. The key difference with YARP is we're written in C#, and we follow the same kind of pipeline model as ASP.NET. In fact, we are an ASP.NET middleware component. And so you can hook us in and use existing ASP.NET middleware components and then add additional proxy components or replace the components we have supplied already to do what you need to do. So if you need to manipulate headers inbound or outbound between like the end user and your servers, those things, you can do those very easily using code that you know how to write. Because of this, the primary ship vehicle for YARP is actually a project. We are an we're a library that you can just reference and use the standard ASP.NET template with a couple extra lines. I'll show those in a minute. We're also looking at giving a Docker image or a standalone exe. So what does YARP actually look like? So the internet comes in on the left-hand side of my screen. We go to ASP.NET. This is where we use the Kestrel web server. That will terminate the TLS. We use the routing and authentication features of ASP.NET. If you want to put other functionality in there as well, you can. If the routes we've defined in config come to us, then our config specifies routes and destinations. And you'll create a cluster, which is a set of destinations that can handle a particular route. So a request comes in. From that, we figure out which route it is, which set of destinations. We'll then enumerate those, and we do both active and passive health checks against those, so we can knock out the ones that are not responsive or having problems. We support session affinity. So if your server needs your requests need to go back to the same server. If there's a cookie already there, we'll use it. If not, you can flag that route as needing sessions, and we'll latch you onto that server, and you'll continue to go back to the same one. We then have a load balancing component. We can use different load balancing algorithms. We'll do passive health checks as we send the request through. And then on the right-hand side, we use the HTTP client set of APIs as what I'm calling a proxier to go and talk to the specific destination servers. So we're really just built on top of the standard ASP.NET and HTTP client APIs and put together an architecture and flow for how these components work to build a reverse proxy. So let's take a look at a demo. What I have, let me start this up. This is a very simple, like basically the empty standard ASP.NET project. And what I've done is added two things to it. So in the services, I've said I want to add the reverse proxy, and I want to load the configuration. And we'll show you the configuration in a second. And then down at the endpoints, we've told it to use routing. We then told it to map those reverse proxy for those endpoints. And so that's where our configuration will come in and add to the route table. So in my app settings.json, I have a reverse proxy section. And in that, I have two things, which is a set of routes and a set of clusters. In this case, I have one route called an example. It doesn't really matter what the name is. And that's mapping to our example cluster down here. So those two names need to match. And then for that route, I've said, I'm going to match any path that is /example, and I'm going to go to www.example.com. So if I do a start, if I start the project, we have a pretty much standard ASP.NET server. You'll recognize most of these things. It's listening on HTTPS on 5001, HTTP on 5000. So if I do a curl HTTPS, and make a request for something under /example, you'll see that it has now gone and proxied. It's got the request of localhost example, and it has gone out to proxying to example.com/example. So it's taking that URL and translating it across. Now that's the simplest version of configuration. So what we can do is we can extend this a little bit further. Where's mouse gone? Here we go. So what I'm going to do is I am going to add another route. Cheat sheet over here. And so what I've added is another route 2, and its path I've just set as a catch-all. As this is less specific, example will win if there's any conflict. Otherwise, it'll come to route 2. And I'm going to add a set of servers for route 2. Sorry, my screen's a different resolution, so the mouse doesn't move across quite like I expect it to. And so for my destination is cluster 2, and that maps to 2 URLs, which is going to be localhost 10,000 and localhost 20,000. So if we save this and we go back, we'll see, if I unclick here, you'll see that YARP is actually monitoring the config file, and when that changes, it will go and update its configuration. So what I can do here is start up 2 servers. So these are essentially exactly the same thing, which is a very simple ASP.NET Kestrel server that will return the properties that was get from the URL, from the headers. So it now, if I go to HTTP localhost and we'll just say foo, then we'll see the first request ended up at localhost 10,000. If I make a subsequent request, let's go into that one. And the vagaries of random number generation, a couple of requests went to the first before we hit the second, because it's doing random load balancing between the 2. So that's a very simple demo of how we can use YARP to proxy multiple URLs to different sites. So that's kind of the basics of YARP. The interesting thing is, in building this, we've had a number of internal teams come to us. Some of those teams are doing simple stuff, and some are a lot more complex. As those teams have gotten bigger and more complex, what they've actually wanted to do with YARP becomes more and more custom. And so what we've actually found is a couple of teams are taking just that, what I call the proxier component, IHTTP proxy, and using that together with Kestrel, and added their own middleware components instead. That's, as far as we're concerned, that's great. They're still using .NET, they're still using the proxy, and it proves our architecture works well for them. One of the most common requests we've had from customers is around configuration. They don't want to have config files. They don't have config files. Everything is in a backend system, such as Kubernetes or Service Fabric. And so we actually have samples on our site. We have a config provider. So you in code basically build up the same structure in memory that the config was, and you can go and pull that data or poll, listen to events, whatever you need, make changes to that and fire a signal to us, and YARP will then pull that latest configuration, gracefully wind down any requests that against the old configuration and start with the new one. The other thing we've learned and realized in this is a number of teams are coming to us already had built their own proxy. They built one for HTTP 1.1, but once they started wanting HTTP 2 functionality, which is requirement for doing gRPC, they were like, oh, this protocol is much harder. We don't want to implement this. And so they looked around and found us and are using YARP to replace their existing HTTP 1 implementation to get gRPC and HTTP 2 capabilities. The other general thing we've discovered is while the RFCs are pretty good, they're not as precise in some places as you'd expect them to be. And one that's really bit us is header encoding is not actually specified in the standard. And so you'll get different encodings depending on the clients and environments that are being used, particularly when it's service calls from devices. You can't even guarantee that they'll be doing the same thing as Edge or Chrome, for instance. And so as a proxy, we've been terminating those requests and restarting new ones. And so being able to match the encoding of what's come in and what's gone out is vitally important to us. On the front end, we're using Kestrel, which is the lightweight ASP.NET server. It's working really well for us. One of our partner teams has been using YARP. They're replacing an IIS and ARR implementation, and they're looking at about 4 times the throughput improvement. So we're very happy with that. The things that we've had to do is harden Kestrel more for suitable for being used on a big service directly on the internet. So we've added a lot more around telemetry. We've added more events. We've added event source and fixed up capabilities with the activity ID tracking in event source. So what that means is when we do our logging, everything is tagged with the activity ID. So from a single request coming into the proxy, you can see every stage that goes through. All the events are tied back to that single activity, so you can track what's going through on a per request basis. We've done a lot of work around TLS and SNI, server name identification. That comes in as part of TLS negotiation to say which site the proxy is trying to serve. It's required in a proxy because you can have multiple sites backed by that proxy. It has to return the right certificate according to that SNI. We can now configure SNI properties that we couldn't do before, and we've added async callbacks. So your code can actually make decisions based on those SNI headers that are coming in. You can do throttling and decide I want to shut connections and things before the server actually has to do much work for it. I showed in the demo, we have reloadable config. So we're actively monitoring the file change notifications for the config, and we'll auto reload when there are any changes. That will also do a graceful switchover. So any existing connections will be allowed to wind down, and new connections will use that new configuration. Finally, we've done a bunch of perf work, primarily around HTTP 2 and gRPC, improving memory allocations, flow control, compression, etc. There's still more to do there. HTTP 2 is a really powerful and great protocol, but there's a lot of work to it. On the other end of that diagram, we're using HTTP client and the HTTP client set of APIs to make requests to the backend server. So the changes that we've done there were particularly around HTTP 2. Typically what would happen is you'd end up with one connection between the proxy and the backend server. and the server can specify how many requests can go on in parallel on that single connection. Typically, it's 100. People are running into the limit because the spec definition for HTTP2 doesn't say whether you can or can't make multiple connections. So we've added the capability in HTTP client to do that and specify a limit to how many connections you can create. So we will fill up whatever the server says is the first the limit of requests per connection, and then add additional connections and make the requests on those as required. We've also been working on callbacks for creating those connections. We did some work in .NET 5 to add callbacks, so that there's plain text stream filter, there's another callback, which allow you to intercept when a connection is made and go and adjust the socket properties for that. You can also listen between the kind of encrypted stream and the rest of the rest of the protocols. You can the rest of the clients. You can do things like encryption, compression, other things that you want to do directly on that stream. Telemetry, again, this was part of the overall telemetry. We flushed those through fully. And so now you can track all the stages of the request process, including the DNS resolution, socket creation, everything back to the incoming connection that was required. We've also added more knobs that you can tweak for whether connections can be upgraded or not. When you make an HTTP2 connection, typically you'll start with HTTP1 connection with extra headers saying it can be upgraded. This allows you to control whether that happens or not, and also whether those settings are cached, so that do subsequent connections, do those do HTTP 1.0, HTTP 1.1, 1.0, etc. Automatically. Finally, we've done a bunch of perf improvements, particularly around the socket support for Linux. We're not done with YARP. We are feature-driven rather than schedule-driven. So we just released a preview 7 today. That should have just gone live. We're going to declare 1.0 when we believe we have the right functionality. There's an epic if you're following what's going on with our planning stuff in the public. More work we want to do in .NET 6 is around connection abstractions, so you can have full control over how connections are created. That will enable us to support things like Unix domain sockets, which is supported now in Windows. Similarly, we want to have control over the connection pool. So HTTP client will create a pool of connections. That can cause problems with some environments with SNAT, which has limits on how many connections can occur from a particular HTTP client to backend servers. So we want to add more control over that to deal with those limitations. We're working with the MS Quick team on support for HTTP 3 and Quick. This is mostly going to affect inbound connections. We don't see as much potential usage with inside the data center, but for connections to the data center, it should have a big improvement, particularly for mobile clients. And then finally, as we're learning lessons from the things that we've built in YARP, so that proxier component, IHTTP proxy, we want to move that into .NET Core itself. Header-based routing we created, that's being ported back into ASP.NET, TLS connection filters, etc. So that's what I had time for. If you have questions, I think please ask them in there. And similarly, come join us on GitHub. We're open source, file issues, etc. there.
Sam, thank you so much for taking the time to present. And boy, do we have questions. I'm going to go about 3 questions since we're going to wrap up the session, and then you can answer the rest at Twitter, on Twitter. Okay.
Okay,
We'll
cool.
go with the first one. Uh, do you have any plan to support for native support for Let's Encrypt in YARP?
Yes, it is something that is on. We have a epic in the YARP repo for what we want to do in 1.0, and I do remember explicitly putting Let's Encrypt on that. We haven't started on it yet, but it is one of the pieces that we want to work on.
Perfect. All right, the next one. Let's see. Can I use YARP as a reverse proxy behind a Kubernetes cluster? So, like, I'm guessing reverse proxy behind the
So
reverse proxy.
yeah, so inside Kubernetes, you tend to have like ingress controllers.
Right.
We are, again, that is one of the things we haven't started on yet, but we are actively working on. We're about to actively work on. We're just getting a set of commits in from one of our partner teams to support Service Fabric, and that's kind of flushed out the requirements for dynamic configuration, and then based on that, we'll be adding support for Kubernetes.
Perfect. And my apologies. I forgot to mention the first two questions. So it was Michael Siska who asked the first question, and this one is Metro Developer. So now we got another question from the Stonehead. Interesting name. What are some of the use cases for YARP? It looks fun, but I don't see it replacing HA proxy Nginx.
Yep. So as I said, the main reason people are looking at us for YARP, looking at us for YARP
Okay.
is going beyond the functionality that is available in those proxies. They're really rich,
Right.
but when you want to do custom weird ass stuff, which invariably all of our services do, typically everything looks great until you're 2 or 3 versions down in your service, and then you need extra capabilities.
Sure.
So one example there is like Antares, which is the Azure websites.
Mhm.
They have so many sites, they don't want to actually try to pull in the config for that up front or dynamically push it. They actually wait for individual connections to come in, individual connections, and then have a cache of the details as to which backend servers are hosting that. That
Wow.
kind of dynamism, that kind of
Yeah.
dynamism level isn't available in those existing proxies without having to crack open the code and do serious work.
Right.
That's
And
where kind of having this more open approach in YARP has helped those teams accomplish those goals.
right, and particularly, and that also gives you the flexibility as a .NET developer. If you want to take some of that advantage as you go, whether it be an app service or anything else, you can customize it yourself, like you said, rather than trying to recompile Nginx.
Yeah.
So,
And you don't have to actually recompile YARP. You're just using YARP modules
right.
and extending those as part of a pipeline configuration.
Awesome. Well, Sam, thank you so much for presenting for us at .NET Conf. And yeah, thank you everybody, and for taking the time to come join us for these past 3 days, particularly the 36 hours of streaming that we had. So that's great. So thank you again.
Thank you very much,
So
everyone.
much.